Good morning. This is the next video for stats section 3.2. We've already talked about regression lines and correlation and calculating the residual, which is how far a point is from the regression line. The residual was what it was actual minus expected. Okay, so we're actually doing, here's a list. We're doing four quick topics today, or quick concepts today. And actually there will be one more video in chapter 3, which will have 4 more short-ish concepts. So we're talking about residual plots and what those are, how to interpret them. And then we have a couple of statistics that we can be able to discuss and interpret. One is S, the standard deviation of the residuals. One is R squared, which is called the coefficient of determination. And then we have computer output that either the book or the AP test will give you. You just have to know kind of what numbers are where. So let's start with residual plots. Okay. So we're going back here. All right, so we're going to refer again to this data about trucks we've talked about before. And here is the best fit line. It is price hat or Y hat, which is the expected price. It would be 38,257 minus 0.1629 miles. And remember, we know we did the regression. We found the y-intercept was 38,257. The slope was negative 0.1629. And so we could use that line to predict the predicted price for a truck with a certain number of miles. And down here we have, there's another example of finding residual. We did this already. For this particular truck that had that many miles with that price, we calculated the residual, which is actual minus expected. Again, the book here calls it observed minus predicted. It's just stuck in my head to do actual minus expected. So the residual for that truck, remember, a residual, that number represents the residual for one specific ordered pair, and it was 68.58, and it's positive, which meant that that truck actual cost was 68.58, more than expected based on its mileage. All right. So that's the residual for one of the trucks. Well, and here's just the data with the line in it, and there's the one truck in question. So instead of finding the residual for 1 point, we're going to find the residual for all, I think there's 16 trucks, right? Yeah, so there are the residuals. So each one, every ordered pair. Now, we're not going to go through we certainly couldn't have the calculator calculate those residuals for us. We're not going to do that. Sorry, mask out here. But that's what those numbers are. For every ordered pair, it's residuals. And it turns out that there's value to plotting those points. Instead of miles driven and expected price, we want miles driven and the residual, which is like how far above or below the line is. You'll notice that these points here, some are above the line. All the points above the line have positive residuals. All of the ordered pairs below the line will have negative residuals. So if I plot, instead of miles and price, if I plot miles and residual, it actually looks like this graph on the right. That's what's called a residual plot. It plots the explanatory variable, the x variable, which in this case is miles driven, not with the price, but with the residual. It essentially takes the regression line and kind of just flattens it out. Any point that would be on the line would have a residual of 0. So there could be some ordered pairs on the line. There don't happen to be any right here. So you need to know what a residual plot is. It is a scatter plot of the x-coordinate with the residuals. This definition, a residual plot is a scatter plot of the residuals against the explanatory variable. And then it says residual plots help us assess whether a linear model is appropriate. Well, let's think about that, because that's what you'll be asked to do. You'll be given a residual plot, and from it you'll have to answer the question, does a linear model appear to be a good model? Well, I would argue that this data, I'm not sure where I just went there, sorry, that this data, I just clicked on some link there, we're going to close that if I go back to this data, I would argue a linear model looks like a pretty good model. Like the data looks fairly linear. And so my question is, what does the residual plot look like for a good linear model? And the answer, ironically, is that there's no pattern at all. Like that's what you want to see in a residual plot. If a linear model is a good model, your residual plot will have no pattern at all. Like if all the points were above or below, or if they started above and then went below, and they get any kind of pattern in a residual plot means a linear model is not a good model. So that's an important concept. Given a residual plot, you're looking for there to be as little pattern as possible. And then they give you an example of, here's an example of, on the left, some data that's obviously not linear. And the residual plot is also, again, clearly there's a pattern in that residual plot. So there's an example where if that's the residual plot you're looking at, you would say a linear model does not appear to be a good model. We're not worried about curved models. We'll do that. We'll worry about that some other time. Sorry about the lights. They seem to go off quicker than usual this time. Oh, well. So that's a residual plot. Okay. I think that's about it here. So there's the residual plot again, because again, that's just blown up. Because I like this sense, because there's only random scatter in the residual plot, we know the linear model is appropriate. So that's just one way to determine if a linear model is appropriate, by making a residual plot. Okay. And we're not going to make them on the calculator. You're just going to be given one and asked to interpret it. Okay, so that's residual plot. That's the first of the 4 topics today. Sorry, scroll back up here. That's what I get for zooming out. I can't. There we go. Okay. All right. Now it says, so we're still talking about how well the line fits the data. And we kind of answered that question by the residual plot. That answered the question, is a linear model appropriate? But as far as how well does the linear model fit? Well, there are 2 other statistics that you have to be able to identify and interpret. And they are, as I said in this slide, one is called F, which is the standard deviation of the residuals. And one is called R squared, which is the coefficient of determination. So let's talk about S, which is the standard deviation of residuals. And the standard deviation of the residuals is exactly what it says. So let's remember from chapter 1 what the standard deviation tells us. So in chapter 1, if we had, let's say, just a set of test scores, and the standard deviation was 10, you had to interpret that back in chapter 1. And the interpretation was a typical test score differs from the mean by about 10 points if the standard deviation was 10. Well, now we're calculating the standard deviation of the residuals. So I have this list of residuals, and remember, some of them hopefully will be positive and some will be negative. And the standard deviation, remember, is always a positive number. It's just typically how far they are from the mean. But the mean here is not the mean, it is from the regression line. So the standard deviation of residuals says how far a typical prediction is from the best fit line. So let me say that again. The standard deviation of the residuals tells us, like, if that, like, well, let's do that. Let's do the example here. So they found the standard deviation. Again, we won't have to calculate. We'll be given it and have to interpret it. The standard deviation is 5740. So let's see if they interpret that. Okay. So here's the interpretation. When we use the least squares regression line to predict the price using the number of miles, our predictions will typically be off by about $5,740. There it is. There's your interpretation of F, the standard deviation of the residuals. You have to say a typical residual is that far from the regression line, but you got to say in context. This sentence here is perfect. When we use least squares regression to predict the price using number of miles, that's my Y using X, our predictions will typically be off by about $57.40. And notice that the unit here is the same as the unit of Y, of the dollars. And that's important because R squared, the next one, doesn't have a unit. But to interpret the standard deviation of residuals correctly, you would need that unit in there. So again, I'm going to highlight it again. There's an important sense. When we use the least squares regression model line to predict the price of a Ford F-150 using the number of miles it's been driven, our predictions will typically be off by about $5,740. So that's what the standard deviation of the residuals is, and that's how you would have to interpret it. Okay. Let's see. Okay, and then the next one is R squared. Now, R squared is in fact the correlation coefficient, which was R squared times itself. Like that's the math that we're doing to do that. So you'll recall with the calculators, you could put the data in L1 and L2, and if you did stat calc ln reg A plus BX, it would give you R. And you'll recall it also gives you R squared. We hadn't used it yet. Let me pull up an example here. Ln reg A plus BX. That's a stupid example. Let me change one number here. Let me make that say 13. Okay, so here's an example where it gives the R value is negative 0.93. So there's a negative, pretty strong linear relationship. And then R squared is just 0.8709. That is, in fact, just the R value times itself. Now, turns out there's more to it than that. So that's why we're able to make a different interpretation. But it is mathematically just the R times itself. So you'll recall, and I know you know this, that R had to be between -1 and 1. Like the correlation coefficient was 0 if there was no linear relationship. It was +1 if the data was perfectly linearly positively related, 0.9 or 0.7 or 0.5, different levels of strength of positive correlation. And then -1 if it was perfectly negatively linearly correlated. And then like -0.9 or -0.7 if it was moderately strong negative. So when I square numbers between -1 and 1, well, 0 squared is 0. 1 squared is 1. -1 squared is also 1. So R squared is going to be between 0 and 1. Just mathematically, R can only be between -1 and 1. So when I square it, it's got to be between 0 and 1. So R squared is going to be 0.83 or 0.28 or 0.91. This particular example, R squared was 0.87. So it turns out that that number has significance for us. And like I said, this is another one of these, I'm going to say, cookie cutter templates that you need to absolutely know when you're asked to interpret R squared. Interpret the coefficient of determination. First, you just recognize that name. The coefficient of determination, that's R squared. And if you're lucky, the question will say, interpret the coefficient of determination R squared. If you're unlucky, it'll just say, interpret the coefficient of determination. You must know that that's R squared. Okay, so down here, I've got a perfect interpretation of it. Okay, so I'll read this, then there's another box down below. It says the coefficient of determination R squared, in this green box, is the fraction of the variation in the values of y that is accounted for by the least squares regression line of y on x. So let me change this a little bit. It is by fraction, we're actually going to use percentage. It is the percentage of variation in y that is accounted for by the least squares regression line of relating y to x. So, and there's a better example down below here that I'll show you and I'll highlight. Let's see. Okay, so actually this is a good this summarizes lots of things. At the end has the perfect interpretation of R squared. So we're going back to my football data, which we looked at the other day. We had number of points per game and number of wins. And there's the regression line, -3.75 plus 0.437x. And then we're given the data. We're given S is 1.24 and R squared is 0.88. So now let's do some stuff here. A says, calculate and interpret the residual for South Carolina, which scored 30.1 points per game and had 11 wins. Remember, we did that last time. The calculated residual was actual minus expected. The actual wins is 11. To find the expected wins, we would have to take their 30.1 points and plug it into the regression line. I mean, they did the math here. Okay, so here's the predicted. They plugged in 30.1. So the predicted wins was 9.4. The actual wins was 11. And so actual minus expected. So there's the residual for South Carolina, 1.6 wins. And there's the interpretation. South Carolina had 1.6 more game They won 1.6 more games than expected based on the number of points. Question B says, is the linear model appropriate? Explain. So here we have a residual plot. And again, what we're looking for in a residual plot is no pattern at all. Now, your question, if you were sitting in front of me, would be, well, if I look at the actual data, can't I tell that a linear model is good? Absolutely you can. But if you're given a residual plot, you need to know that you're also looking for there to be no pattern. So B says, because there's no obvious pattern left over in the residual plot, the linear model is appropriate. Perfect. Okay. Now, C and D, these are new today. C says, interpret the value of X. And up here, it gave us S. S was 1.24. You've got to know that that's the standard deviation of the residuals. And so the interpretation is that's how far a typical residual is. That's a lie. That's how far a typical ordered pair is from the regression line. But you have to say that in context, which is said down here for answer part C. When using the least squares regression line with X equals points per game, predict Y number of wins, we will typically be off by about 1.24 wins. That's exactly how I would interpret S. When using the least squares regression line with X equals, whatever the X is, to predict Y equals whatever the Y is, we'll typically be off by about 1.24 Y wins here. So again, you should, other than changing points per game, number of wins, and 1.24 wins, those would change based on the context. Other than that, that sentence is perfect. And then here's the first time we're seeing the percentage of variation, which is what the coefficient of determination R squared tells us. Up here, it gave us R squared was, I lost it, 0.88. So here's the interpretation. About 88% of the variation in wins is accounted for by the linear model relating wins to points per game. And again, wins is just a unit for Y. Relating wins, there's Y, and there's X. And that's all, yeah, I'm doing something bad over here, sorry. So that's all the interpretation does. And here, this is the box to key on. I like this. Again, I've said this before. Whenever in your book you see one of these AP exam tips, read it carefully because they're designed to be helpful. It says students often have a hard time interpreting the value of R squared. They frequently leave out keywords in the definition. Our advice, treat this as a fill-in-the-blank exercise. So, right, on our example, 88% of the variation in wins is accounted for by the linear model relating wins to points per game. There's no reason to just say more than that, but you for sure don't want to say less than that. So if R squared is 0.88, 88% of the variation in Y is accounted for by the linear model relating Y to X, and you have to say in context. So there's going to be variation in Y for other reasons, but this is how much of the variation can be accounted for by that linear model. So again, this box right here, you must know how to interpret R squared. And then I'm going back to part C. You also have to know how to interpret the standard deviation of the residuals. When using the least squares regression line with X equals points per game to predict Y, the number of wins, will typically be off by about 1.24 wins. So those very common to interpret S and interpret R squared. All right, last thing today is just instead of being given, let's look at this stuff right here. It gives you the equation. There goes my lights again. It gives you the equation of the best fit line, and it gives you S and it gives you R. That's a nice way for that to be presented to you. Well, sometimes there's different computer software programs that give output that the AP test likes to present. You have to know what's there. So this is the one that's by far the most typical. So it's the one we're going to look at. Minitab is just the name of the software package. So this table just let me clarify this. Just this, not this stuff over, not there. Just this. I guess by zooming out, there it is. I lost my ability to write on the screen, which is weird. Go like this. So we're looking at this output this Minitab output right there. Okay. Now, if I zoom in, I think that blue box will still be there. I don't know. It will be. Okay. So And I believe this is about, this is the mile, this is the truck data. So we had miles driven, and we were predicting the price. So you'll notice this table, I will say that, and I'll change colors here. Actually, my pen's down again. Maybe it's not. Yeah, it is. That these columns over here, sorry. These columns over here, we don't need. We just need the two numbers under the word coefficient, and then the bottom row. Here we have S equals that. You've got to know that's the standard deviation of residuals. And when you're given output, it won't say standard deviation of residuals. We'll just say S equals. And there's R squared. That is, in fact, R squared, which is your coefficient of determination. And then these two numbers, you'll notice that the headings here, this says constant. That's the y-intercept, 38257. That was my y-intercept in that Ford truck example. And the miles driven, since that's my x-coordinate, the number right there is the slope of the best fit line. So from data like this, you should be able to calculate or write the equation of the line. It would be y hat equals 38257 plus 0.16292 volts. You should be able to use it to predict something, because now that you have the line, you can plug in a value to find a prediction. You could find a residual for a particular ordered pair, and then you could interpret the standard deviation of residuals, and you can interpret R squared. The one thing that shows up also here that is interesting is, what if it said this? What if this said find R? What if it wanted the correlation coefficient? Well, let me go back to my table here. You'll notice that this table did not give me R, but it gave me R squared. R squared was 66.4%. So R squared is 0.664. This computer output gave me that R squared equals 0.664. What could I do to find R? Well, that's just solving an equation. I could square root it, right? So if I use my calculator and I square root 0.664, I get 0.815. Now, we've got to be real careful here. I got 0.815. When I say be careful, I mean you've got to know that, remember, that R could be positive or negative. Both positive 0.815 and negative 0.815, if I squared them, would get an R squared value of 0.664. So you got to pay attention to, should R be positive or negative? And how do you know that? Let me go back to my slope. The number is very small. I'm just going to circle it right there. That 0.1642, that was the slope of my regression line. Since in this case, that slope is positive, that means R would have to be positive 0.815. If the slope of the regression line was negative 0.1628 or whatever it says, we would still square root R squared, but then R would have been negative. Just, I know one of your homework problems asks you to calculate R. Be aware of whether it is positive or negative. Okay, and I believe, let me scroll out here, make sure I'm not forgetting anything. Come on. It's not working. Okay, let me scroll down here. If I go next here, we're on to the next. Yeah, we're done. So that is, we just talked about all four of those things. We talked about residual plots, standard deviation residuals, coefficient of determination, and interpreting computer output. And then the assignment based on this. Oh, that's not what I meant to do. I meant to go here and here. And the assignment here is, homework is on page, I lost the page, sorry. Starting on page 194. And we're just doing numbers 51 and 52. And we're doing 55 through 60. And today's Friday, we'll make that due Monday at 11:59 p.m. As you know, we're going remote the next 2 weeks. That's not going to change much since most of you are remote anyway. I've got one more video for chapter 3. Certainly the week after Thanksgiving, we'll be doing a test on chapter 3, because one more video and we're done. So there you have it. Have a great Friday and be safe.